Hi, everyone. I hope y'all enjoyed your little break yesterday, and we're getting closer and closer to Thanksgiving break and then eventually Christmas break, which is exciting. I know I'm excited for that. So, fun times. All right. So, on Friday, we talked about adding, subtracting, and multiplying polynomials. Okay. So, starting to get into something a little new, and that was kind of a refresher for you, hopefully. So today, we're going to start looking at kind of the opposite of multiplying polynomials, and that is factoring polynomials. So you may remember factoring that word from before, specifically looking at maybe factoring binomials, which means with two terms, right? But we're going to be looking at polynomials, which just means many terms. So we're going to have 2 terms, 3 terms, 4 terms, as many as you can think, pretty much. So let's start off with make sure that you filled out on your exit ticket already the no column for your KWL chart before you continue with this video. So if you haven't done that, go ahead and do it right now and then jump back on. Okay, and then we're going to start with this factoring worksheet. So I think it's attached as a PDF on your Schoology. And we're going to start with looking at A, B, and C at the top right here. So go ahead and pause this video and try to do A, B, and C on your own. So A just wants all the factors of 24. B wants the prime factorization of 72. And C wants you to find the greatest common factor within that fraction 36 over 48. So try those 3 on your own and then come back to play this video when you're done. Okay, so hopefully you got a chance to work on those, figure out anything about any of those 3. So let's go over those really quick. This is pretty easy stuff, especially A. So when we think of listing the factors of a number, it's any numbers that we can multiply together to make that number, which is 24 in this case. So all you had to think about was, what numbers could I multiply together to make 24? Probably the easiest one is 1 and 24, right? If we multiply anything by 1, it's going to be the same thing. So we can already write down we have 1 and we have 24. Okay, and I'm going to write this hopefully in numerical order, but you don't have to. It's just a list. Okay, so we have 1 and 24. Let's think about the next number after 1. What about 2? Can we multiply 2 by anything to make 24? So the answer is yes, we can multiply 2 by 12 to make 24. Okay, so 2 more factors in that list now. Okay, let's look at the number after 2, 3. Can we multiply 3 by anything to make 24? Yes, we can multiply 3 by 8. Right, 3 times 8 is 24. Okay, what about 4? Can we multiply 4 by anything? Yes, we can multiply 4 by 6. Okay. Now let's think about after 4. We have 5. Can we multiply anything by 5 to make 24? No, we cannot. So that would have to be a decimal or fraction, right? We're looking for whole numbers here. So we can't multiply anything by 5 to get 24. And then after 5, we had 6, which is already on our list, so we don't have to list that again. You can check the numbers between the other ones at the end. So like, for example, 7, but we most likely would have already listed that with a smaller number to get 24. But 7 doesn't work. Let's see, 9, 10, 11, those don't work either. And then you could check all the numbers between 12 and 24, but none of those work either. So that's going to be our complete list of the factors of 24. So you just go through and see what numbers can I multiply together to get 24. And that's going to be your list of factors. Okay, so let's look at B. This one, it wants the prime factorization of 72. So not saying what are the factors, right? But it wants the prime factorization of 72. So what we're going to do is see first, how many times can we fit multiplying 2's into this 72? So let's start with just basic 2 times 2, which is 4, right? Okay, so that's 4. We're not at 72 yet, but what if we multiply it by 2 again? So that is 4 right here times 2. That would be 8. Okay, so then add another 2. 8 times 2 is 16. So we're not there yet, right? Okay, and then we're going to add another 2. So that would be 16 times 2. That's going to be 32. So we're getting a little closer. So let's think about if we're going to add another 2, that would be 32 times 2. 64, so we're even closer, so we can't add another 2. So I'm going to write that down here because I ran out of room. Okay, so that was 64. If we multiply 64 by 2, that's going to be bigger than 72. It's going to be around 120, right? So what we're going to have to do is probably backtrack a little bit. So let's erase this 2. So what we had before 64 was 32. Okay. So let's think about now, instead of multiplying by 2, if we multiply that by 3, so we had 32 times 3. So that would be 96. That's too big still, right? So what about if we take away another 2 again? So let's see what we had before. 32 was 16. So let's see if we multiply 16 times 3. That would give us 48. Okay, so now we're building back up to that 72 again. So let's add a 3 there. Now we're at 48. Okay, let's see if we multiply 48 by 3, what do we get? So that's going to be 144. So let's backtrack again. Let's look at taking away another 2 possibly. So if we take away that one, that gets us 2 times 2 times 2, which is, we said 8, right? So if we multiplied 8 by 3, that is 24. Now what about if we multiplied 24 by 3? That is going to get us that 72 we were looking for. So we ended up having 2 times 2, which was 4, right here, and then 2 times 2 times 2 was 8, multiplied 8 by 3, and then multiplied the 24 by 3, and that got us 72. So our ultimate prime factorization here was 2 times 2 times 2 times 3 times 3. So that's if you're going to write it as a list, but you could simplify this and say we have 2 in there and we have a 3 in there, right? And then how many 2's do we have? We have 3 of them, so we could put that 2 to the third power, and then we have 2 3's, so, and then times 3 squared. So that's how you could write that simplified. All right, and then let's look at the last one, C. So this one gives us the fraction 36 over 48, and it wants us to simplify it using the greatest common factor. So we've kind of already done this, just solving equations and stuff like that when we have a really large fraction and we think, can we reduce this fraction any? Well, what we're doing when we reduce it is taking out the greatest common factor. So the greatest common factor is a number that you can take out of both of those numbers on the numerator and denominator. So look at 36 over 48. are there any numbers that we could take out of both of those? Now, you may think, well, both of those are even, so we could take out 2 out of each, right? But remember, we're looking for the greatest common factor. So that means we could take out 2, but we could also take out more than 2 probably, right? So take a look at that. Think about what is the greatest common factor we could take out of both of those numbers. So it's actually going to be 12, right? If we take out a 12 out of 36, what do we multiply by 12 to get 36? It's going to be 3. And then what do we multiply by 12 to get 48? 4. So we're taking out 12 out of both of those numbers, reducing that fraction to be 3/4. So our greatest common factor here was 12. Okay, now let's look at together this right here where it says polynomials. Okay, so right here it gives you this long mess of terms. Okay, so first it has some terms in parentheses next to each other. Remember, if we have those parentheses next to each other, technically those are being multiplied together. That's the math going on between them. And then it says that equals just a list of those terms being added. And then that equals a simplified version of that middle part. So look at that for a second, and I just want y'all to think about this question below it is, what are the factors exactly? Do you think it's that first part, or do you think it's the middle part, or do you think it's the last part? So think about that for a second. So the factors for this are going to be that first part where we have 2 different things in parentheses. So those are the factors for that middle part, or even the last part, which that last part is just a simplified version of the middle one. So the factors are 2x plus 3y, and then times 4x plus y. Okay, so that is just getting that what the factors even look like into your head. And now we're going to start moving on to how we factor in general. So for this, we are going to have a lot of different methods of factoring, okay? Basically, we're going to go through each one on different days, and when we use each of those factors is going to depend on how many terms are in our polynomial to begin with. So we're going to either have, we're going to look at having 2 terms, okay? We're going to look at having 3 terms, and we're going to look at having 4 terms. So each one of those, we have a different way that we factor those polynomials, okay? But the first thing we're going to do, whether it has 2, 3, or 4 terms, is we're going to take out the greatest common factor to simplify that polynomial for us. So that's just what we're going to be looking at today, is taking out a greatest common factor of these polynomials. So let's look at this first example right here. Okay, so it says 6x squared plus 14x. So we're looking for a greatest common factor. Obviously, they all have a greatest common factor of 1, right? We want to see if there's anything else we could take out. And we're looking for the greatest one. Okay, so what do both terms include? I see they both include at least one x, right? The first one has 2 x's. That's why it's x squared. This one has 1x. So we could take an x out of both of those. Okay, so we know we're going to take out an x. But now let's look at the numbers. So the first one is 6 and the second one is 14. What's the greatest common factor for both of those numbers? Let's see, so we could take a 2 out of the 6. That would make that 3, so that works. And then we could take a 2 out of 14, which makes that 7. So 2 would work, but let's check. What about 3? We could take 3 out of 6. Could we take 3 out of 14? No, so we're going to go back to that 2. That 2 is going to be our greatest common factor. So our greatest common factor is in total 2x. Okay, so will we write that with our factors, as if this is going to be our final answer? We write our greatest common factor first, which was 2x. Okay, then we're going to write the polynomial, but with that 2x taken out of it. So we said if we take 2 out of 6, that makes it 3. Okay, we also took an x out, so now it's not x squared, it's just x on that first term. So that 3x is matching, or was that 6x squared right there. Okay, now we're going to look at the 14x. Okay, so we took out an x, so now it's just going to be a constant. It's not going to have a variable with it. And we also took out 2, so 14 divided by 2 is 7. Okay, so that is our final answer with the greatest common factor of 2x taken out of it. Okay, so now let's look at the next one. So we have example, and I'm not going to read that because that's very long to read. But y'all can see what it says. So we wanted to consider the numbers and the variables. We have 2 variables here, a and b. So we might have to take out 2 different variables depending on if we can. Okay, so let's think about the numbers first. So we have 4 on the first term, 6 on the second one, and -10 for the last one. So what would be the greatest common factor we could take out of all of those numbers? It's going to be 2, I believe. So if we take 2 out of 4, that's going to be 2. 2 out of 6 is going to be 3. And then 2 out of -10 is going to be -5. And I think that's going to be the greatest one. We can't take 3 out of 4. We can't take 4 out of 10. So I think 2 is going to be our greatest one again. So we can go ahead and write that down. All right, now let's consider the variables. So what about a? So on the first term, we have 2 a's, since it's a squared. And then on the second and the third one, we only have 1 a. So that means the least amount we have is that 1 a, right? So we could take out 1 a from all of these terms. Okay, now what about the b's? The first one has 1 b. The second one has 2 b's, and the last one also has 1 b. So again, we have at least 1 b in every term, so we can take out a b as well. So our greatest common factor is 2ab. Okay, now let's write that polynomial with that greatest common factor taken out. So 4 divided by 2 is 2, and we took out 1a and 1b. So now in this first term, we're just left with 1a. Okay, the second term, 6 divided by 2 is 3. We took out 1a and 1b, so now we're just left with 1b here. And then on the last one, -10 divided by 2 is -5. And then we took out an a and a b, so on this one, we're just going to be left with a constant since both of those variables are being taken out. So that was how we find the greatest common factor and take it out and write our final answer. So like I said, with all these methods that we're learning, no matter how many terms it has, the very first thing that we're going to check for is if it has a greatest common factor. And if it does, we're going to go ahead and take that out to simplify it for us. And most of the time, it makes our work a lot easier. Okay. All right. So once you've finished your notes on this, okay, you're going to go to Schoology and finish your exit ticket that you pulled up with the no column. So you're going to finish the W and the L column on that and make sure you submit it. And I'll see you all next time.